Hello and welcome back. In this lesson, we will be looking at computing products. When I say computing products, you can see here we have all these options starting from the virtual machines, which the pyramid, if you can see here, the base is as model, that is infrastructure as a service model. So when it goes down, you would be ending with the platform as a service model. So let's have a look on it. What are the products that are at this point of time in Microsoft Azure that can fit and where it is fitting. So if you see here virtual machines, they are you have the more control on that. So it falls into the infrastructure as a service, as you know. So though when you say VM, if you're quite completely new, a VM is a physical machine you create as an isolated layer of machine to utilize the existing hardware resources, and that's called the virtual machine. And the similar thing, you can also create the things like VMs within the Microsoft Azure. So in this case, VMs is the first layer, and also you have other one as the virtual machine scale set. So the similar VMs will be duplicated things will be available for you. So in case if the workload is not able to handle by one machine, you have thousands of machines or hundreds of machines can be serve the end user's request. Now this a new thing has been added here is called containers. If you can think about a container is a microservice layer where like a fabric a service fabric specific like Dockers and Kubernetes, all that comes into the container. So it's a microservices, and you also have app servicing. So this is where the applications and other things can be hosted under computing. And also you have the functions or FAAS or fast. The functions as a service also can be used, which just needs a logic and an event based driven application. So we're going to look on it in a minute, and this will have all these different technologies that would trigger the functions and other things. So this is finally ending with the platform as a service model. Now let me show you what I'm trying to talk. If I just go to Microsoft Azure portal, and for all services, if I just go to all services and under computing, you have here 32 as a date of this recording, 2020 January. You have here 32 different services. Some of them are in a preview, like SAP HANA is one of the major thing. They wanted to bring SAP HANA to Microsoft Azure platform, so that's still in a preview mode, and such things are completely part of Microsoft computing services and products. So within this, we talked about the virtual machines. This is where you can create virtual machines, and you have the virtual machine as a classic model. So when we say about the classic model, we don't have ARM or Azure Resource Manager. If you remember the ARM or ARM model, so that is not there with the classic model. So it's a ASM model or servicing model. That's a completely different, but nobody is using now ASM model. Everybody is migrated to Azure Resource Manager model, that is ARM model. So you can check out here what are the virtual machines you can create here and such things. So for all of these things, you do have a proper planning of what kind of workload you wanted to migrate. Let's say you wanted to start with, you want to migrate an existing application, then you goes to this left side workflow. Otherwise, if you're trying to build a new one, you just try to fit where actually your applications can fit. Let's drive as a new application, like your application, whatever you're trying to deploy. Do you need a full control on that? In that situation, it goes to the virtual machines, like say data and everything for the financial institutes or such things, like a lot of complexity for configuration and installation. Then it goes to the virtual machines. If not, if it is high performance computing, when we say high performance computing, you wanted to run as a batch of that workload, then you need to end up with the Azure batch as the one of the service. If the applications are wanted as app service model, you can go for the micro architecture model. If not, you want to have a kind of a kind of event driven completely workloads, then you can just pay for only Azure functions, so that you're no need to have any servers or serverless technology. When we say serverless technology, don't get into confused state. There will be a server, but the server is not managed by us. So the server will be available from the Microsoft server, but what we do is when that specific event triggers, it's gonna, for example, you order an order and that mail has to be triggered. So when an event triggers as the purchase has been completed, you need to send an order confirmation email to the consumer, so that drives a event model. So during that milliseconds of time or a second of time, you're going to use the functions. So you would be paying for only that second time, so you're not paying for the entire infrastructure. Whereas in the virtual machines, you need to pay for the virtual machine complete cost of that processing and the memory, everything including as a consolidated. But here with the functions, you are actually paying for only the event driven based. And if you're looking for full-fledged orchestration, then it would actually goes to the container services. And if you're looking for some kind of fabric model or the container-based like Kubernetes, other things comes into a different technology altogether, like .NET integration, other part. So now this is for the new applications if at all we are trying to develop. Now, let's have a look on it. If we have already an existing application, can that be migrated as it is, or can we convert that and fit it into Microsoft Azure, one of the product services, into the computing environment? To check with that, like if you are trying to build or migrate an application which is as it is to migrate to the cloud, that means there is no changes required to that specific workload. That's called lift and shift. So if it is already cloud optimized, you can directly lift and shift. The workload type would be the cloud optimized. If you are trying to do the cloud optimize the existing workload, you may have to consider HPC or high performance computing workload for the Azure batch mechanism. So batches, as we discussed, it's a multiple, the code will be executed on multiple computers, so that way you get the supercomputer power altogether. Now let's have a look on a lift and shift. This can be containerized. If that's the case, you can look for AKS or Azure Kubernetes Services or app servicing model. That's what we have looked into here, like the microservices model. If not, you may have to consider for the app services or for the virtual machine model. So you might have understood by this time. This flow will give you a good idea how existing resources or existing applications can be converted, or when you're trying to design what kind of workload it's going to be end up with, and based on that you can design it. Let's have a look on in the Azure console. You have this here, the Microsoft virtual machine. If you're trying to create a Microsoft virtual machine, it would ask you for a specific operating system and the image that you wanted to install. Let's say you want Ubuntu or Red Hat or Windows Server operating system, or for that matter maybe Windows 10 Professional. And this is where the hardware size, which talks about every operating system or every virtual machine will have a sizing capacity. When we say sizing, it also talks about the cost, along with that how many CPUs it's going to have and how much RAM it will have and what is the performance of the disk operations. So based on these virtual CPUs and RAM and disk performance, this has been segregated into a sizing. So when we say sizing, sizing consists of 8 different models. Let's see, you have here D1, D13, different models. So if you look at any of these models, it is mostly it is optimized based on a category. If you see here, it's a general purpose. This is memory optimized. That means you'll have a more memory. And if you just scroll down, like GPU is more, that means it's going to cost more, even because it has a graphical performing unit, that is a GPU you have within that NVM model. So the VM sizes depends on the model of that VM that needs to be understood and the resources that we used, and every VM will be optimized for a specific type of workload. For example, here GPU and storage optimized here. You see here, that means the more IOPS you have here, 10,000, 8,000, that's huge IOPS. And at the same time, the RAM and memory is nothing but the RAM definitely, and the CPUs, all that would be optimized for the VM. So we would choose the required family of that specific product. Let's have a look on it. If I just go back to again to the all services, if I just go to all services and try to create virtual machine scale sets, so that means it same virtual machine is gonna have multiple machines in the background. Let's say you wanted two instance count, or you want a close to 1,000, any of the for example, I can give here as 100 VM scale. So that means the same VM will have close to 100 in the background. So if one goes down, other one would automatically takes up. So that's the power of cloud computing. Now let's have a look on about the pricing. So when you look at the computing pricing, when you go for a normal model called a pay-as-you-go model, which we normally discuss every time, like the performance of that, like there's no upfront cost, but you would be paying for the minutes that you are going to use. To long term commitment or upfront commitment, there's nothing like that. So you just have to buy that specific service for some time, and then you would be terminating that VM or that specific service later point. But there's something called a reserved virtual machine instances, where you're gonna save close to 72% of the saving when compared with the pay-as-you-go model. The main advantages for this would be applications with the steady state, and the customers who want at a budget predictability, and customers who are committed for that VM for a longer term. So that's called the reserved VMs. Again, in the reserved VMs also you have here 3 years and 1 year model. So when you go for the 3 years, it would be very less cost. If you see here, BS1 model with the 1 gig of RAM, which is costing you close to $0.00 $0.004, that means it's very less, but whereas here it's costing 6. So 2 cents are costing higher comparatively. And if you go to this again, 2 more percentage has been increased. So when it comes to the spot instances, sometimes the spot instances will be available for you with a discount of 90%. When we say spot pricing or spot instance, that kind of VMs are freely available from the Microsoft data center. So instead of they lying as a free, you can run some kind of batch job and come out of that spot pricing or spot scale set of that VM. So that way you would be maximizing your savings, at the same time you are actually doing your work. So this is very much useful for the customers who want to significantly lower their cost and interruptible application. It doesn't matter that if that specific application got interrupted, it can wait for a notice period of 30 seconds and in advance before the application is affected. And that situations you would go for this, and you would be saving close to 90% of the cost when we look at the costing model. So these are the things coming to the pricing for the computing. And you can go for the calculator. The calculator would give you a good idea in dollars how it's going to be like. You wanted to spin up this VM maybe in South Asia or maybe in US or Norway or whatever the region, and based on that the operating system you would be choosing and the instance. So this is where it says that per hour it's going to be cost you just the 2 cents. Think about it, it's just the 1 GB or 9 GB of the RAM. It's even 9 cents, which is very low in terms of cost. So this is 18 cents. So think about virtual computers are so cheaper when compared with our on-premises. Let's move to the virtual machine scale set. So within the scale sets, let's say you don't want to do a lot of customizations and maintenance work, that things like that, but you wanted to make the machine to be workload to go down, or instead of going down, instead of that, if you just go for the virtual machine scale sets, what would happen is a pool of it's a pool of set of virtual machines that it automatically scales based on your traffic coming into your virtual machines, and then by auto scaling it does it in the both directions for the up and down. When we needed more service, it just creates multiple virtual machines close to 1000 as the maximum limit where you can go for the machine. So it's auto scaling is possible for automatically create or spin up some more virtual machines for that workload, so that your users doesn't know that they don't experience any kind of latency or maybe a workload becoming slow. So for them, every time the machine would perform as they wanted with that high availability and that good performance, they would get it. So let's have a look on the basically the difference between when you look at the manually. If you want to scale up, it takes a lot of time to do it, manual process. Instead of that, virtual machine skill sets will create from a single central place, so that it has the same image or same disk it will have, and it would just simply clone that image for spinning up another machine. So that way it would automatically create and integrates with your load balancing and your application gateways, so that it knows that what kind of workload is what kind of traffic is coming to these specific workloads, and that would actually helps to spin up or down the set of virtual machines. And then this is also comes into the infrastructure as a servicing model. Now let's have a look on it as your app services. If you just go to all services of Microsoft Azure and then you have the web, this is where the app services come into the picture. So like you have the app services, this is where you can create your own custom apps, which is a web-based applications, and then that can be scale up, scale down, all that can be done. So what exactly app service? The app service is a platform for us to build and host applications, which are a web-based application, mobile backend, and it will have the RESTful APIs and it gives us a lot of flexibility. Our applications can be in any programming language that we want. For example, if you can see here, this is a base. Either you want to choose as a Linux or Windows, you can choose based on that plan, and you have the app service plans also. And you see here you have the programming flexibility where you can choose any kind of programming as one of them, like .NET or Java or Python or Ruby. All these PHP, all these are possible to choose for your web-based applications. And this kind of flexibility gives us we don't need to have to manage any of the infrastructure, whatever. So again, and these are the platforms as a service offering. We don't have to manage anything that's underlying these services. Instead, Azure manages it for us and offers auto scaling, high availability. We can support both Windows and Linux operating systems, which is really cool. And since we are hosting web applications, there's automated connectivity between various source codes and the repositories like GitHub, Azure DevOps, or maybe really any Git repositories. And for that matter, this app services gives as an on-demand auto-scaling web applications and the API hosting platform that runs on both Linux and Windows. The infrastructure as a service equivalent would be as setting up virtual machines and then setting up the web server, and wiring things like that would take a lot of time and money for us, and we would also have to worry about auto scaling. We would have to worry about load balancing, all kind of things like that with the infrastructure as a service when we try to host anything on a virtual machine, this kind of web application. Instead, with the app service, we just have to upload our code to the app service, tell it is what kind of operating system we want to run our code, and what kind of app service that we wanted to handling, with what kind of language. And that's all. We can, once we have configured that specific things, it can handle auto scaling or and everything for us automatically, and this makes us always up and running for us. And also for us, you have the options to run these services into the Docker container, so that you can choose what kind of Docker services you want as an operating system for Windows Docker, or maybe a Linux Docker. All that also can be possible to do it directly from here. When we look at the containers, if you just go to the all services, you have the containers options. So this is where container services got depreciated, but you have the Kubernetes services here. And if you just go to the Kubernetes services, this is where you can create your Azure Kubernetes services. This is so easy that what kind of Kubernetes version you wanted, and you can go for the Kubernetes clusters within the Azure also. You have a look on it here, and when you just create, you have a plans, and you have the scaling option, what kind of auto scaling or multiple scaling, all that possible options you have with the Kubernetes version, what version you wanted to deploy within the Microsoft Azure service as one of the Kubernetes cluster. And this is where you normally create the Kubernetes services. You have option to increase or decrease your node size and the number of counts, but if you increase more, it would actually throw an error, as the node couldn't support. So you might make sure that your subscription is supported, all that to be verified and checked. Let's take one of the business case that or one of the business example when we use the Kubernetes or Docker services. Suppose you have a work for online clothing retailer, a company that is planning to deploy a handful of internal applications, but hasn't decided it how it's going to host them and what kind of hosting model you're going to choose it. But they are looking for maximum compatibility as a first option, and second one is the apps may be hosted on premises, or maybe in Azure or any other cloud provider for that matter. But some of the applications might share infrastructure as a service model. In that cases, the company requires the apps isolated from each other. That means the apps can share the same hardware resources, but they don't want to be able to interfere with other files and memory and other resources that are used by other applications altogether. So the company values the efficiency of its resources and wants something with the compelling application development story. So then the Docker seems to be an ideal solution. What exactly Microsoft Azure Functions? Azure Functions is an event-triggered or event-driven or compute-on-demand experience that extends your existing Azure applications platform with compatibilities or capabilities to implement a code triggered by events occurring in Azure or third-party services, as well as on-premises systems. So it's not just limited to the Microsoft Azure. You can also extend this to happen on your on-premises systems too. And Azure Functions allows developers to take action by connecting to the data source or messaging solutions, thus making it easy to process and react to the events. Developers basically can leverage Azure Functions to build HTTP-based API endpoints accessibility by a wide range of different applications, mobiles or IoT devices. Azure Function is a scale based on demand, so you would be paying for only the resources that you actually consume, or when it actually triggers the time it has taken, only for that only you would be paying for that. So let's jump into the pricing, and you can check out the pricing side. If I just go to the calculator here, within the calculator you have functions. Within the Azure Functions calculator, if I just open up this calculator, the first 400 terabytes of executions, as well as close to, this is 1 million executions, are free per month basis. And post to that you would be charged the first time. It's almost free for you. Post to that you may have to pay by by based on the execution, like for example, if you go to the pricing, you would be knowing that what exactly it's going to charge. And for basically, this is basically used mostly for the IoT and other devices. So this is a kind of booming technology now on functions as well as technology. So this is the charges page you can check out, which I'm gonna attach this as one of the resources for this lecture. I hope this is useful for you. I will wrap up this lecture for now, and I'll see you in the next lecture. Thank you for watching this.